Hello, and welcome to my Capstone video. In this video, I'll be showing you my project, Reimagining the Helmet for the American Fire Service. I'll start out by introducing myself, telling you a little bit about who I am and why this project is important to me. Secondly, I'll take you on a little bit of a side trail, explaining an internship that I did alongside this Capstone project. Thirdly, I want to give some backstory or a why for this project. I then want to walk through a little bit of the research that I did in preparation for my deliverables, and finally, my execution of those deliverables. So first of all, who am I? My name's Jonny Yoder, and I'm a 28-year-old industrial designer from Partridge, Kansas, a very rural part of the country. For some time, I've known that I'm likely genetically predisposed to cancer, and I know this through some of the stories of some close relatives. And this will make sense a little bit later as to why this is relevant. Secondly, I'm an industrial designer that's passionate about solving real problems with practical and concrete solutions. Finally, I love fire trucks. Like many kids, I loved fire trucks, but unlike most, I never really grew out of it. And these three things, while they seem disconnected, are part of my identity. They're certainly not the whole of my identity, but they're things that I care about, and they've culminated in this project. But first, I want to talk a little bit about this internship that I did. This past semester, I had the opportunity to work for Sutphen Corporation in their sales office. Sutphen is a company here in Dublin, Ohio, that manufactures fire apparatus. And when I say apparatus, I mean fire trucks. So if you hear me use the word apparatus later in this presentation, that's what I'm referring to. So this was its own project alongside of my capstone. And while there wasn't a lot of overlap, there were opportunities to let the two influence each other. My main role in this internship was creating sales drawings for the sales department. These drawings are for the dealer and their customer to better understand the product that they are ordering or that they would like to order and have manufactured. This drawing is a mid-mount aerial platform for the city of Orlando. Sutphen is a unique company in that sales, manufacturing, and engineering all work in close proximity. And this helped to expand my interest and knowledge in the manufacturing process of this type of product. It also gave me a really good up-close look at quality design and engineering that's right here in Dublin, Ohio. But a highlight was FDIC, or Fire Department Instructors Conference, where I had the opportunity to go to this expo in Indianapolis with the sales team. While there, I was able to meet dealers, customers, and show off our cool trucks. But another highlight, one that is relevant to this capstone, is that I was able to walk around a little bit and meet some of the other vendors that were there. This one particularly was MSA Carnes, and they build fire helmets as well as other products for the fire service. Now, while this was rather late in the game for my capstone project, I was still able to use it well and to ask some questions about helmets that are currently on the market, hold them and understand them, take pictures of them in a way that I wasn't able to just by looking at them online. So for me, this internship was an opportunity to observe design in action. Also was an opportunity to learn some basic professional skills and time management. But the big takeaway there is that it actually helped me build a career. In fact, I plan to start with this company after I graduate as a full-time sales territory manager. But for the project itself, this was good because it gave me an immersion in the fire service culture that I might not have had otherwise. It also gave me some great network opportunities and conversations. It was a great chance to meet customers and see how quality design impacts their lives. So now back to my project. Why do I care about the project that I've undertaken for this capstone? Well, I want to start with the big problem, the big question, and that is of cancer in the fire service. The NFPA says that firefighters face a 9% increase in cancer diagnoses and 14% increase in cancer-related deaths. There are a number of reasons for this. I recently had the chance to talk with Dr. Caban Martinez from University of Miami in Florida, and he explained some of the elevated risks that firefighters face. Some of this is from just poor lifestyle decisions, and while that certainly doesn't reflect all firefighters, it does reflect a few, and that's one area that they are putting their health at risk. There's also the genetic predisposition that I was talking about earlier, And then finally, there's also on the job risks, on scene risks. And this is the area that I want to focus on specifically. This is coming from several areas. One that I didn't get into much in this project is the issue of chemicals in turnout gear that are actually creating cancer risks for firefighters. Now, this is an issue that created some lawsuits, a lot of news articles and things were done on this. And as far as I know, this issue has kind of been resolved with manufacturers really responding to some of the issues and the complaints, the lawsuits that were happening. But that is, like I said, not something I really dug into in this project. Secondly, there's what I would call in service risks. So it's often said that when firefighters aren't fighting fires, they are cleaning something, whether it's the toilets in the fire station, whether it is the ambulance after tuberculosis call, or maybe even just washing down the truck. They're often putting themselves, or they're often exposing themselves to chemicals, harmful cleaning chemicals, even just while they're in service. And then finally is the on scene risks, the risks at the scene of a fire. Modern fires are increasingly toxic with battery fires and even with just modern building materials. And these release carcinogens even after the fire is out. And then firefighters will take that dirt home with them on their gear, and that dirt is making them sick, simply put. So, my focus is how can I design for cancer prevention in the fire service? I wanted to look first at some of what's already being done. A common response to this is the extraction machines, which are simply put really beefed up washing machines that fire stations have that spin the gear really fast and that wash it with a special detergent. Then there's, of course, other products related to this, like giant drying racks and things like that. There's also gross decontamination. This is part of a protocol that a lot of fire departments are putting in place where firefighters will wash down right after exiting the structure fire, and their gear is washed down before it is then bagged up and taken back to the station separately. But I wanted to take a little bit of a different route with my project. I wanted to look at one of two icons in the American Fire Service, either the fire helmet or the fire apparatus. So I asked this question: could either one of these products be redesigned to fight cancer? Now, I know these are very different from each other, but this is how wide my scope was at this point. I thought maybe I could put some kind of addition or product on the fire apparatus that would help firefighters decontaminate, or I could maybe look at the helmet and what I could redesign there. So these were two directions I saw the project going, but then I had a really pivotal insight following a conversation with an Upper Arlington captain who said that fire helmets are often an overlooked part of a firefighter's cleaning routine when he gets back to the station. And here's a bit of a journey map pointing that out. They will take their gear, their other gear, throw it in the extractor in the washing machine, and then they will often neglect their fire helmet, maybe just a quick wipe down, mainly because it will be wet for the next call, and they don't want to risk putting a wet helmet on their head, so they might neglect it. And unlike their bunker pants, their bunker coat, firefighters typically and almost never have a second helmet, and they are inconvenient to clean and disassemble. So, with this problem in mind, I wanted to start with some physical design guidelines for redesigning or designing a fire helmet. First of all, I want it to be easily disassembled. I want it to be easily cleaned and then easily replaced. Now, I don't want to just buy into our disposable culture, but I did want it to be something that if it was compromised or just dirty beyond reasonable cleaning, that it could be replaced easily. There were also some other considerations. I was a volunteer firefighter for a number of years back in Kansas, and I understand that in rural, underfunded departments that are often staffed by volunteers, tight funding can often mean that health and safety issues are overlooked. So I wanted this to be something that could be available for firefighters no matter what their status or what kind of department they work for or their funding. Also wanted to be accessible, something that's easy to understand and get your hands on. And finally, I wanted to be visible. Not visible in just that it can be seen, but visible in that it's a symbol of taking care of the rest of your gear, not just your helmet, but visible in that it stands out as a reminder that hygiene habits are important in the fire service. So let's dive into some research. My biggest source in my research was my interviews and some of the contacts I had there. So special thanks to these individuals who helped me out. This was not my only source, but it was significant in informing and shaping the trajectory of my project. And it was in these conversations that I was able to create somewhat of a persona. This isn't one person that I met, but he's maybe a culmination of some of the men and the women who are serving their communities every day. So Jake, 48 years old, he's been working in the fire service for some time. He cares a lot about his health, not just now. He wants to be healthy at the end of his shift to go home and see his kids, to visit them at college, whatever. But he also cares a lot about his retirement. So he's worried about those health risks that'll catch up with him later on down the road. And like I was saying earlier, some of his pain points have to do with wet turnout gear, gear that's difficult to disassemble, whether that's his helmet or his bunker pants. And then there's just the constant stress about his health. So creating this persona helped me understand who I might be designing for. So he cares about his health, but he's also really traditional. And that's what leads me to some of the products that are currently available. On the left, we see some of the traditional helmets being used by American firefighters. There's the ultra traditional, which is a leather helmet. These are steeped in rich culture in the American Fire Service. There's also composite helmets that are made to look a little bit like the leather helmets. So they've kept the form, but have left that material and some of the function of it. And then there's also some more modern style composite helmets that are worn. Often you see them a little bit more on the West Coast or in rural areas. But then on the far right is the jet style helmet or European style helmet. And that's on the far modern side of the spectrum. And these have almost wholesale been rejected by American firefighters. American, Canadian, and even South American firefighters have rejected these helmets almost exclusively because of their looks. So you'll see them more typically in European and Asian countries. So I saw this gap here and I asked this question, how could I design something that maybe has the aesthetics of the traditional style that would be more easily adopted by an American firefighter, but that would also have some of the cleanability and the lightweightness, some of the perks of a European style helmet. And this is where I actually then pivoted to focus simply on the liner, and the exterior of the helmet could be saved for another project. I was also able to obtain a fire helmet from the city of Columbus, thanks to them for offering me this condemned fire helmet. Here I was able to take it apart, which was an opportunity for some empathetic research because it allowed me to see what a firefighter might go through, taking care of their helmet, disassembling it to clean it. I was also able to just do some product research, see how a helmet is made, what components make up this type of helmet. And then finally, it offered some great prototyping content for me as well, which you'll see a little bit later. So for the execution itself, I started out with sketching, like any proper designer. And you can see towards the bottom where I was still sketching the whole helmet, but then later, in the bigger sketches that you see in the bulk of the page, is where I then switched to focusing on the liner itself. I wanted to look at a couple parallel, or maybe even barely parallel, but similar markets. So I started with the football helmet. Now, football helmet has these bubble type paddings, and I looked at that as something to draw inspiration from. And while it offers a lot of impact protection, I was struggling to see what it was offering me in terms of thermal protection, as well as the adjustability that I was looking for. I then looked at BOA systems. These are often found in lacing up snowboarding boots, hiking shoes, and even some biking shoes. And while I liked the way that this could possibly tighten the helmet around a firefighter, it still contained too many soft goods and possibly pinch points, or at the least, places that would catch a lot of dirt and water. So I moved away from that ideation as well. What I ended up settling on is actually, for inspiration, is actually a Formula One seat. And this came out of a conversation that I had with one of my instructors, where I learned that Formula One seats are actually molded to that particular driver. What's unique about this and what felt relevant to this project is that these seats contain minimal padding, minimal soft goods, and yet are incredibly comfortable because they are molded specifically to that user. So I thought, how could we, with 3D scan and print technology, do the same thing in a fire helmet, where we could mold that lining, that interior lining, to the firefighter's head, and it would fit every time without adjusting. And then it would also be easier to clean because it lacks the tightening mechanism and some of the soft goods that other liners have. So from there, I went into Gravity Sketch. Gravity Sketch is a virtual reality program that allows you to sketch and model in virtual reality in 3 dimensions. This also was a good opportunity for me to use a mannequin head to build my sketch around, to build my model around. This is also where I was able to, for the first time, ideate on the concept of an inner and an outer shell for the user. From there, I went into prototyping. Prototyping helped me as the designer understand the form I wanted to work with. It also provided great content for overlay sketching later on, and it allows me as a designer to demonstrate to you, the audience, my concept in a tangible form. I started out with taping a foam mannequin head. This was very basic. This simply just kind of allowed me to see how the different curves and contours would move around the head. But then I quickly went into molding my own head. My original idea had been to 3D print something, but I struggled with the printer and also wasn't sure how I would get it to fit my head, and that seemed to be important for this project. So I ended up using plaster of Paris, which I then set in epoxy to harden and give it structure. Here you can see those two halves on the left, and now they're flipped up, set in epoxy there in the middle picture. And you can see it fit to my head, the inner lining against my head, the outer lining to fit and mold to the inside of the helmet then, which you see on the right side. Here's a rendering of what those look like from an exploded view. And this rendering actually then allowed me to take it a step beyond prototyping and bring in what I would call an integrated thermal barrier and ear flap. So helmets are required by NFPA to have ear flaps to cover the firefighter's ear, the back of his neck, but then they have a separate piece that's a thermal barrier inside the helmet. But I thought if we could combine these two into both thermal barrier and ear flaps, then sandwich between the inner and the outer lining, you could then remove that as one piece and wash it with the other soft goods. Here are some of the special features that make up my design guideline of being easy to disassemble and assemble. First of all, a single screw on either side connects the whole lining assembly to the helmet shell itself. From there, the two liners can pop apart with just a simple snap like that, and the soft goods can be removed from between the two. And then finally, a single strap for the chin straps to also be removed and washed with the other soft goods. So how might this look for the user wanting to wash their helmet? First of all, they can unload the dirty gear from the truck that's been gross deconned at the scene. They can put their bunker coat, their bunker pants aside. And then when they go to disassemble the fire helmet, it's a simple screw on either side that allows them to remove the whole thing from the helmet. From there, they can separate the two halves, remove the thermal barrier and integrated ear flaps, throw them into the extractor with the bunker gear, and then scrub the hard goods in the sink. From there, they can reassemble the helmet and put it back into service in very short order. What I imagine happening is, like with the bunker gear, they would have a second dry piece that they could put back into the helmet while they wash the other ear flaps and integrated thermal barrier. So, have I met my design guidelines? I believe that I have. This product, it is easy to disassemble, it is easy to clean, and it is accessible and non-disruptive. Part of the reason this is a good design is because that you can't see it. The design goal that I have of being accessible to more traditionally minded firefighters was met in this. So for the next steps, I'd like to briefly consider where this project could go. I don't plan to take it here, but here's what would need to happen for this project to move forward. First of all, further manufacturing, research and development would need to happen. Obviously, seeing how it works to scan someone's head and 3D print a piece that fits them specifically would be an important part of this. And then, of course, product testing and NFPA certification. This product would need to undergo rigorous testing to see if it's a viable product for the market that would keep people safe. So finally, I don't only believe that this is a helpful product in and of itself, but I believe that it is a stepping stone toward more health conscious products in the future. I believe that it bridges the gap that we have in the fire service between innovative products and the tradition that often bogs down that innovation. I believe this product bridges that gap. Thank you for watching.